Thank you very much, Damilola. Very, very good presentation. But as I was listening to you, I was wondering, especially when you spoke about this being available on open source. So I'm wondering, is this project for you a CSR, right? Or are you looking at this as is it for, not for profit, is it for business, right? If it's for business, what do you then gain by making it available on open source? Have you thought about patents? How do you keep your rights to this solution so that it then makes sense? Obviously, if it's CSR, then it's fine.
As much as I'm trying to say that it's not CSR. So I already have a cost of production and I have an idea of how much it's going to be. Also, I before making it open source, I'm definitely going to get like patents or likes on the idea. But for someone in a software space, yeah, the way open source projects work, right? When people contribute to open source, they still give attribute to whoever original, the owner of the original idea. I get especially with so that's just the whole idea of bringing on some open source here, not necessarily attaching the idea just contribute.
I think most of the questions have been asked. So what I'm going to say now is more of some admonition, more or less. My view after listening to you, and I like the presentation materials, in fact, the way you put it together. And it looks fantastic as an academic piece of work. Very fantastic. Now you're in the prototyping stage, and that's when you begin to talk to the industry outside of the academic space. Now, if you're going to build this kind of device, especially for medical applications, I'm sure there are some regulatory bodies and there are some steps in oil and gas, call it technology maturation processes. It's 6 stages. There are some processes you have to follow before you can deploy it on the market. The presentation didn't talk about that, which is why I said as an academic piece, it's good. But if you're going to share this beyond this session, you need to begin to think of presenting it to the industry, in which case you need to know who your regulators are, what processes are involved in the mass producing it, and what your technology maturation process or steps will be for acceptance. That's your thing.
I think I also mentioned the support needed because I've read on regulatory compliance of medical devices, starting from how to register it with NAFDAC, under NAFDAC one, and also the members of if I need to come to be able to register because I need a medical personnel on it. So those were some of the support. I also highlight. Thank you very much.
Round of applause for our wisdom. Things are getting serious. So, without wasting our time, we move on to the third presenter, person of Mr. Joseph Balogun, our mosquito king. All right, your time starts now.
Good afternoon, panel of judges. Leeds committee, ably represented by Age Shola, my colleagues, and to everyone else who has graced this occasion. I'm Joseph Balogun. I'm here today to give you a quick run through my air project, and more importantly, to share with you the goal it holds for humanity by the time it comes to that. Next slide, please. Yeah. Why the four silver mosquitoes? Why are we overly worried and concerned about this insect? I'll show you. Every year, over 500,000 people lose their lives to malaria alone. Now, when we factor in other mosquito-borne diseases like yellow fever and dengue, we're talking about over 1 million lives lost annually. And you might want to agree with me that it's terrible enough to lose aged people to non-natural causes of death, like an insect. So this makes these statistics disheartening. It says that over 80% of those who lose their lives are kids below the age of 5. We're talking about boys and girls deprived of an entire lifetime because of this insect. So these statistics shows that undeniably mosquito is the deadliest creature on earth. So having established that this is a menace, this is a threat to the human existence. So what's being done to stop the bad guy, so to speak, in his track? Next slide, please. So over the decades, government of nations and health organizations have come up to fight mosquito. And I'm positive that virtually everyone here is familiar with some of these efforts, maybe mosquito nets, insecticides that tackle mosquitoes. But for time constraint, I'll only touch base on 2 of them as they are of interest to the project. Next slide, please. Next slide. The first one I'm making mention of is the genetic mutation of mosquitoes. Several years after the discovery of a certain bacteria called Wolbachia, new generation scientists thought it good to bring it on board and see how it can be used to combat mosquito and the diseases they propagate. So what is Wolbachia itself? Wolbachia is a bacteria that inhibits the production of insects. So the name Wolbachia is what gave birth to the project Wolbachia. And what does the project Wolbachia entail? Mosquitoes of the species Aedes aegypti, which is known for spreading yellow fever and dengue, are bred in a facilities in Australia, we have in Singapore, we have in Brazil, Indonesia, as far as I can remember. So mosquitoes are bred in their millions. Sounds very interesting. Also found it so when I discovered. They are bred in their millions and injected with this bacteria called Wolbachia. To what end? To what goal? So after they're injected, they are then released to areas where dengue, yellow fever are prevalent, so that they can mate with female Aedes aegypti mosquitoes. And when they mate, they introduce this bacteria, the same bacteria, into their reproductive system and render them sterile. So what has been the outcome of this interesting approach to combating mosquitoes? Let's see. Next slide, please. So results from the Wolbachia initiative. You can see a quick run through of summaries of the results. 0 dengue cases in Kings Region, Queensland, that's an area in Australia. Dengue cases have dropped to the lowest level in 20 years in Colombia's Abura Valley. 80% drop in cases of dengue in Singapore. I just picked this out of several scenarios. So overall, according to stats taken in August 2022, the Wolbachia project now protects more than 10 million lives in regions across the globe. In my opinion, I'll say it's a success story. Now, the second approach I'll be talking about is this. While studying the mosquito to find avenues in which they can be made less of a threat to human existence, scientists discovered an interesting phenomenon: the mechanism by which male mosquitoes are attracted to female mosquitoes. When female mosquitoes take flight, they emit sound. The beating of their wings emits sound at a certain frequency. And any male mosquito within a 10-meter radius is able to pick the signal and zoom in to meet the female mosquito where it is at, and then they meet. So efforts are being put in place to exploit this understanding of mosquito behavior to develop a device that tackles them. However, I want to point out that this effort has only been tested in male Aedes mosquitoes. Efforts have not been done yet to see how it can be exploited in tackling mosquitoes of other species. such as the male anopheles mosquito, which is of relevance to us. Next slide, please. So the big idea here is to replicate the love hearts, but this time, instead of targeting the male Aedes aegypti mosquito that causes yellow fever and dengue, we want to target male anopheles mosquito, which is a counterpart to the female anopheles mosquito that causes malaria, which is what we are battling with in this part of the globe. So the idea is, instead of going after females, the males should be lured to the trap. And I think it's an interesting one because it's going to have an effect like the project for backyard, but from a different approach. Instead of rearing the male mosquitoes as it's been done in the project for backyard, a very, very expensive undertaking, we are taking the male mosquitoes out of the picture. So by taking them out of the picture, the females over time will now have mates to populate with, and over time, it will lead to a reduction in the mosquito population. And when there's a reduction in the mosquito population, of course, there will be a reduction in the diseases we propagate. And I introduced to you, next slide please, a conceptualization of my project. I called it the LAMO, mosquito killing lantern. So from the base, you have seen the base for support to compartment, and then the Arduino Nano, that's the embedded system that we programmed to give us sound at that frequency, which we call the love hearts. So the Arduino will be connected to speakers, and see speakers from the sound module. So and then the sound comes out of the device through those perforations. Remember, those perforations are sticky. They contain a sticky substance so that when the male mosquitoes are hearing the sound, they try to find their way into the center of the device. And as they venture towards it, they get stuck inside of those holes and they are trapped and they are killed. So this is like a better view of how the device looks like. So I imagine that we have this in every home, in every office, and every street. We can deal a major blow to mosquitoes and the disease they propagate, especially malaria in our part of the globe. As I wrap up my presentation, I've got a less than 30-second clip I would like to show you. Yeah, so earlier I talked about the love hearts in attracting male Aedes aegypti mosquito. So this sound has been captured and coded into a mobile app far away in Australia. So this is it. So the sound is played from the phone, and you can see the mosquitoes swarming in to the source of the sound. Please play it again. So the idea here is to, instead of targeting male Aedes aegypti, we'll be targeting male Anopheles mosquitoes. Thank you.
with partners.
Once again, I want to commend your beautiful presentation. But I have an issue. Are you aware of the present animal life, what they call them, the NGOs?
Threat to wildlife.
Yeah. Because aerosols designed now, they are not meant to kill insects. You want to just render them invalid. Because they claim things, the animals to outright. Are you aware of that? So, how is your work dealing with that? That's number one. Then number two, the existing design in the market. How far do you go about
very much for the questions. I'll start with the second one. There are existing devices on the market, as you said, but they make use of blue filter light in attracting mosquitoes. Over time, it has been discovered that this is not effective because it stems from the lack of proper understanding of how mosquitoes behave. So mosquitoes are not attracted or repelled by blue light. So in fact, these devices, instead of attracting mosquitoes, they are attracting other insects like moths, butterflies, which of course are of more relevance. They are pollinators. So the devices are failed, and that's what brought about my idea of coming up with a device that actually kills mosquitoes without tampering with other insects like moths, butterflies. So now talking about preservation of wildlife, rights, animals have. Of course, they have rights, and this project is not about eliminating mosquitoes out of the world entirely. We want to reduce their population. So if we have to reduce their population, we can preserve life. So it's not about what matters more. Is it the human life or the life of the mosquito?
No. You said mosquito is the deadliest animal or creature in the world.
Statistics show that, sir.
Yes, our population in Nigeria is climbing up. So it's not really dealing with us the way the way you pitched it. If it's that deadly, we should be dying as a collective in terms of population. But yet, our population is going up more and more. So I would tend to disagree with that statistic.
I like comments, sir. I like one. And I respond to that, sir. It's still, we are over 7 billion now. So if a million people die, you might not have noticed. So these statistics is something that we should release over year. And I don't know if you would agree with me, but it's a general knowledge that statistics from the WHO is verified. So,
That's on the side.
right,
Okay, case of natural whatever,
okay,
natural selection. If we preserve those lives, by now maybe we'll be 300 million people with yet not enough food or houses to feed us. So maybe it's God's way of balancing things. I don't know. I don't want to get into that. I missed something from your whole presentation. I'm wondering if this is a pitch for the start of your project or it's something that's nearing the end of it. It sounds more like telling us what you have done as a project. So can you explain where you're at in your project?
so it's not a pitch. What is been going on, bringing this alive. I acquired the end. What I will call the and show the design piece. So I'll call this the, more or less the engine room of the device, the embedded system, and I acquired that this week. It got to me on Thursday. So what I started on programming it. Once that's done, the other part work over more or less. So it's a project that I would say is 60% underway.
I didn't get to your presentation, bro. It sounded to me more like something you want to embark on.
Oh no, on it already, sir.
Very, very interesting presentation. I have two feedback for you. The first is about your presentation style. You know, when you started, at some point I was wondering, this is an engineering project. Where is it going? It took you a bit it took some time for you to actually uh, get to the point of what you were trying, the message you were trying to pass across. I think the preamble was a bit too long, just some feedback. And also, okay, so I'm in finance, right? So it would have also been nice to see the economics of this idea, right? Because you don't just want to kill mosquitoes, you want to make money while you are reducing malaria, right? That's your idea. So it would have been nice to see the financial bits of this project. But very nice presentation.
Thank you, sir. Thank
Joseph, you need mosquitoes, are you? It's like they've shown you pepper in life. So if just to ride on what he has said and other people, when you are putting together a presentation, especially when you want it to have some commercial value, not that you're just finishing it up so that you can get your BSc. There is a way you pitch, there's a way you present, there's a way you carry people around. You've done well. But you are so concerned about how you are going to deal with mosquitoes. That was all that was on your mind. Now, from an environmental perspective, what do you do when you are inventing anything or being innovative? You have to look at what is the trend, right? And look at what other people are doing. You are targeting the male mosquito, but the people who give us or the insect that gives us the problem is the female. So what you are saying is that you want to eliminate mosquitoes from Nigeria. Effectively, that's what will happen if this device goes into practice. Now we don't know, aside from the fact that they bite us, mosquito has a place in the ecosystem of Nigeria. Maybe it's because of them that there's oil and gas. You don't know. So no, on a serious note, you need to have that background research. Now what do they do? Once a female mosquito bites us, she dies. So the male guy is not your problem. It's the female that is your problem. She's the one you are really supposed to be ignoring. Now you need to know her. She died already when she bites you. What are the interventions other people do? Even though that may be bad, they sterilize them. Some of the methods they do sterilize them. They don't kill them. So you need to be a bit gentle about your method, especially that you are targeting men. Imagine if it was all male bees that were being killed, which bee makes the honey, I'm not sure. You understand? But you need to also be careful that they are not just concerned about this mosquito that just bites. That's not how even after your project, you can actually but very good. Well done.
I join others to congratulate you. You carried us along. Although at the beginning we were wondering where exactly we're going. So I have 3 points I noted here. First is on the economic feasibility. Didn't see anything on that. That has been said earlier. Now, from this your design, how many mosquitoes will this apparatus, how many mosquitoes will it catch before cleaning is required? No, because when you're providing a solution, you also need to be mindful of who will do the cleaning. Would it become an annoying thing, for somebody to have to be cleaning and cleaning each time mosquitoes fill up this place? And personally, as a person, I don't mind mosquito biting me. It is the sound that I hate. That is what disturbs me. So if your machine will be producing sound, will that sound become annoying to the human being or to the mosquitoes?
you. To answer last question, thank you. To answer the last question, the sound, just as the video, the short video that was played, the sound is a such a frequency that it doesn't serve as disturbance to humans. Just like just as cats and dogs are able to pick sound that humans can pick, this sound is emitted as such a frequency that only the mosquitoes can pick it. So to humans, it's not a problem. Now, the economic value, okay, I think we've addressed that point. Thank you. Okay, the number of mosquitoes it can trap and kill before cleaning is required, um, that has not been looked into yet. So I'm afraid I can't give a concise. All right, all right. Thank you. So it's now be permanent on it. Yeah.
Thank you very much, Mr. Joseph. That's male mosquito, not the female ones. So what spider is determined? Person or this the big makeup will be presenting tabletop melon shadow. Melon is a bit interested. I hate peeling melon. I have 15 minutes, but yeah, always after now I discovered that we have about 200,000 most of the people I discovered that about 400,000 most people like some of us end up only that some of these problems come from obesity is known to solve problems like diabetes. But if you are using the solution, if you have the solution and it solves the problem, what I'm saying is that if obesity can solve diabetes and other problems, and then you end up taking it, thinking that you try to solve the problem, you end up creating more problems, which is this is Musa, a young farmer who is trying to scale his business in melon shelling. He's trying to increase his efficiency, production cost, income generation, but then he has various ways to do it. It's either it goes for ant shells, which is labor intensive, semi-industrial scale ABC melon sheller, which costs about 360,000 naira, or it goes for an industrial scale ABC melon sheller, which is about $5,000. Musa is a low income farmer and hence cannot afford all this. This ends in economic instability, low productivity, and then would have to resort to unskilled labor, which is labor intensive. So these are the solutions. We need need a safer melon shelling. We need a portable and mobile mechanism that we can carry because we see that if you go for a semi-industrial scale ABC melon sheller, it's an heavy duty melon sheller which is going to be difficult for you to carry. If you want to go for the industrial scale ABC melon sheller, it's also very expensive and difficult to transport or even import to the country. Now that it's even in dollars and the way our dollar to naira ratio keeps fluctuating, it's going to be a difficult purchase. You also need an efficient and user-friendly melon shelling that can be used by peasant farmers with low technical ability. Fast and durable home sheller. If you are going to use an home sheller, it's supposed to be considerably efficient when compared to hand shelling method. And with this home sheller that I'm proposing as a solution, we have about 500 grams of this melon sheller being shelled in 1 minute. What currently purchase 25,000 naira as the proposed price. If you compare this price to the ones I've mentioned before, 3,000, 360,000 naira and the $5,000, you see that 35,000 naira is way better as the purchase. Energy. Those two melon shellers that I mentioned earlier, the semi-industrial one has about 3 horsepower power consumption and also the one of the industrial one has about 5 horsepower. Now, the one I'm proposing is just 350 watts. Next slide. Long-term goals. Economic empowerment of farmers and local communities. Musa is now able to shell melons with ease at low power consumption and at a faster rate, provide a chain of employment. During the production process, we would have workers working in production, in the distribution sector, marketing, and sales. Research and development to enhance technological features. We also have benchmark for efficiency in melon processing. Ideally, when you produce a device, you would always have competitors, which will also spoil it to be much more efficient. And yes, we're going to have benchmark for efficiency in melon processing. It will also boost technological literacy and skill development in the local farmers. Next slide, please. Now, the innovation. The idea of the melon sheller is to imitate the same way you are going to shell a typical melon seed. This melon seed. They are going to break this bit of fingers into two. And that is the idea where you have the inner shelling mechanism and the outer shelling mechanism. Now, when you pour the melon seeds inside this shelling part, it's going to get stuck in between these two, and the shelling process is going to occur. Next slide, please. The concept and design. What makes this design different from the previous ones? When I made my research on existing designs, I discovered that most melon shellers have their motor and their fan connected together, which means that if you are going to be connecting the main motor to power the sheller and also to power the fan, that means you need a very high efficient motor, about 3 horsepower, which leads to high power consumption. So what did I do? I separated it and looked for a motor that will have higher RPM, that will be able to separate the already broken shafts from the melon seed. Also, this is a Chinese model of melon sheller that has been done already, that is existing. But you discover that this type of melon seed looks like a pot, which means that naturally by compressing it, it will break. But the kind of egusi we have here in Nigeria is the flat type, which if you compress, nothing happens. Which means that this design cannot work for us. And here is the proposed design. Next slide. In fact, the end users are small scale farmers who are unable to afford the semi-industrial and industrial scale melon shelling machine. Agri cooperatives and agro processing units who end up helping and assisting farmers in rural areas and also even in the urban areas. To my surprise, when I did a market research and survey to find out about existing melon sellers in Ibadan, I went to the Potidia market here, which is like the main market in Ibadan. I met with melon seed sellers and I asked them that I would like to locate the nearest place I can shell equity, and they said I have to go to the share. Yes. So that shows that if in Ibadan, where you have major markets, and they are selling melon seed, they have to go as far as the share to have the melon seeds being present. Now, where is the problem with the market women is if I were to be a food seller, and every time I frequent a market woman and I buy the already cooked melon seed and I cook it, and then my customers come around and complain that my business is happening with that taste. Where's the bitter taste from? Things that have oils in them experience what they call acidity. Acidity is oxidation of oil-based seeds. Now, in Bodija market, this market women expose their already shared seeds to the atmosphere, and the seeds experience acidity, which can lead to food contamination as well as the bitter taste of the seeds. Now, the woman who is selling her product, who is selling food, end up having issues. The same woman who is being invited to go and bed to come and cook will end up having issues. The same market woman who has already purchased shared APC seeds will have issues because if people don't come and buy on time, those shared APC seeds will end up spoiling. So, government, in terms of government, we have health because now the government can channel their money into other aspects of health-related activities because we reduce food contamination in terms of the businesses. Also, job opportunities are now being created in the line of processing of these businesses. Before we have jobs in manufacturing, distribution and sales, maintenance, repair and services, transportation, packaging. Also in entrepreneurship, if this melon proposed ABC seller costs just 35,000 naira, an average university student can purchase it. And this can form entrepreneurship in universities among our youth, creating employment opportunities to make ABC power, to make ABC oil, to make ABC base and also to make ABC leaf. Most importantly, the ABC leaf is a good substitute for human milk for children who have lost their mothers. Impact, economic impact, we have the consumer health, which has been spoken about before. Time saving. This machine is 16 times faster than the hand shelled method. Increased processing efficiency to about 66%. It takes 1 hour to shell 3 kg. If you are using your hand, it takes 3 hours to shell 1 kg. Public job opportunities, over 150,000 proposed along the chain of employment. We have entrepreneurship, which I've already spoken about before. Next slide, please. Now, feasibility. Before you can say that trying to solve a problem, there has to be a demand. About 1 million tons per annum of electricity is being consumed. That shows that a lot of Nigerians consume electricity already. We also have collaborative partnership with IIT and cooperatives who every time conduct research and try to partner with private companies to assist farmers in the country. We have pocket-friendly direct purchase. Farmers can now purchase directly because the price of the melon sheller is very, very cheap. It is pocket-friendly purchase. That means it is feasible for farmers to now afford it. We have the light weight and portability, as you can see. This is not a complex carrying a machine that is almost as big as a paper grinder. We also have alternative manufacturing. Now, what makes this design unique is the alternative manufacturing. Let's assume that this is Nigeria, we import materials. Now, let's assume that we cannot afford to machine, pass it through the machining process. We can also pass it through the docking process. And most of these, the materials are used existing parts. This which is existing dimensions. I do not create a new dimension and say I'm trying to solve this problem. I solve the problem using existing dimensions. This is an existing 5 dimension. The sheller is also made of existing 5 dimension. These are the existing bearing parts. I'm not creating a new bearing dimension. So that means I find through what I can have around me to solve the solution. Also, if you look at the exit part, the melon sheller, the site of an average plastic you can see that have around you. which means that if for any reason you are unable to import materials or pass it through some certain engineering processes, it can result in using existing designs or existing materials around us. Next slide. These are the methodology, material selection, which I've already done, design and prototype development, initial testing. I'll be showing the testing video, final construction, okay, final construction, quality control, and user training program development. Next slide. So, still our time. The status of the work. I've done the component design, which I've shown before. The components have been purchased. The sheller mechanism prototype used with plastic and wood. I did because it's a food-based machine, it's supposed to be stainless steel. But this is the prototype thing. Imagine stainless steel is very expensive, and then you are using stainless steel every time to test run. That's why I've used plastic and wood. So moving on, the first test run was and we had 55% efficiency due to sheller material adequacy. Display. The first test run, which you have here. We have this inside the main housing channel using locally sourced materials. And here we have it shading here. And we can see that we have exit ports here, exit ports here, here exit, initial exit, and escaping. This shows that when you make a prototype, you encounter errors and then you try to improve on them. Today I'm going to be showing the second prototype design that has been done and is so you see that why this machine was done is stability very quickly. We have to sustainable. That's why I'm quite very other problem I think that from this error that I've been able to reproduce a much more standard and
All right, thank you very much. Def-
Thank you for a very engaging presentation. The only question I had, you actually answered it before you rounded up. That for full contact surface, it has to be stainless steel. And you actually answered that. Well done.
so like I said, this is one design like I repeat again. As you can see, this is it. Now I'm supposed to be stainless steel. I'm just using this. That's why it's and let's not forget that if it is made of stainless steel, it can definitely have sharp edges. It cannot have enough package to use, which was like 55% efficiency. And another one is being used here as well. Like 55% efficiency. Like you need to know which is what I've already proposed. This is easy, and that is our plan. Then second point, operating temperature. so fast that I covered this part. What I'm saying is this. When you want to share with your person, you have to add it to what it is, which makes it easier to find. When you want to share what you want to see, you add this one also for it to go to see, which is like just so that alone is low because you have a little bit of moisture to make it. Also, there's a two animated online thing that does the shaft. When that part does the shaft, you have to plastic tape.
Yeah. But this one is the last one. So which is the last one? Okay. I love everything of your presentation, and I think you touched on almost all the critical areas that I would have loved to see. You spoke about market potential. You made comparisons to existing processes, solutions in the market. You did a market analysis, go to look at market. And when you brought the saying date of you spoke about patents. So I think you basically had almost everything covered. You also spoke about health and safety. Now, in terms of the target market, I'm a big confused who your target market is. We started with Musa, the farmer, then we went to market women, and then we came to socially, so I'm wondering who's your target market. You need to be clear about who your target market is. And also maintenance of this and after sales. So if you sell and something spoils, how readily, easily can this be maintained and can whatever part that gets spoiled be fixed. But overall for me, I think it was a really, really wonderful presentation.
Well done. Good. I just have two questions. What power rating are you looking at?
When I start seeing power because of the level of weight added to it, now I'm having a shout. Go for the weight. And that was why I was not focusing on it. This shows that I need to have what an higher power rating. Inside the inside the I already specified that which is the same rating as energy blenders that we have in our house. So I'm looking at that projection. So, I mean, most times we use our blenders, we don't have use of power rating, so why not look at something like that? Right.
Are you sure? You need to learn something today. I'm sure. Yeah, I never knew the cake. You see, milk, that's something I mentioned. 35,000. So, last final is for today. Let me say something. I can come back. Decide to go up. I don't need slide. I can present my head. So, you have to pause for. Good evening. My name is my name is Mr. Rapid. So I'll be presenting to you experimental application of solar artificial intelligence using applied Bluetooth mode. So basically adopted like that allow another material. This is adopt that adopt that surface surface light between absorbent and adopt. So in my own case, I has been why I adopted first part that the fact sun is the let's just say most abundant energy generation area going forward with 136 megajoule per square. Now that is what is radiating from. So now what comes to the earth? We have 1,000 megajoule per square. That energy, okay, we have 14 trillion in this thing when we make comparison to energy consumption of the earth 2022. Now we have understood the fact that there is energy availability somewhere from the sun, and at the same time we understand the fact that at times we have abundance sun and have abundance of heat. So we have not always have sunlight every day. And as a result of that, how can we what problem can we solve with the available one? Like when we have abundance, what can we do? The first approach is save it. That when we don't have it, we use that harvest energy when we have abundance. When we don't have abundance, we use that energy storage. Now there are different technologies using thermal storage approach like district materials. But in this case, I'm not actually bringing that on board. Basically, I'm just using the energy that is available during the sunlight. So the first problem is that availability of energy. That the main concept we are looking at here. Now we have over 703 million globally that don't have access to electricity all at all. And in Africa, we have 600 million people, which is always 3% of the region. That means we still have some people that don't have access to energy all at all. As a result of that, they cannot even imagine having cooling or having what they have natural condition. And as part they just use cooperative methodology, maybe open their water, having water, so when there is heat, maybe now the truth of the matter is another fact because of COVID, our body temperature does not. Now, if it does not, there will be a problem. As a result of that, our body was maintained at a 7 degree Celsius. As a result of that, we discovered that right now on Earth, especially in Africa and Nigeria as a district, there is the ambient temperature that is 1 degree Celsius, meaning that as a result of having ambient temperature at 41, we are pools have agency energy from the ambient with our body, which may actually increase our body temperature to 39 degrees Celsius, which is very, very harmful to the body. That's number one. So according to International Food Policy Research Institute, the cold storage accounts for 45% of food deterioration in developing nations. That is, and let's just say $47 million as a result of the cost implication on farmers. Now, what that thing is all about is that post-harvest problem is being discovered there. By post-harvest problem, I tease that not, let's say we have 1,000 capacity as Nigeria. If 45% of this gone, then we are left with 5% to struggle with. The fact that the population is not productive, we don't have adequate systems for agriculture. That's so. Just say we are increasing productivity and basically reduce by using waste by putting technology or let's call this coaching, then the input to prevent this problem of food generation. Now, the third problem basically is 95% of grain-fed agricultural value is affected by the environmental impact of change. What does this mean? Now, sub-Saharan Africa, we don't have, we are not practicing mechanized farming. As a result of that, the adverse effect of climate due to carbon emission and the like is going to really affect us and is going to make sure that we are having our food security, which is really very, very bad on our side. And who knows? We are actually not at the point that we are not the one contributing so much to the carbon reduction emission. And the last one is that approximately 1 people rely on facilities that have no electricity supply. As I speak, if you go to the usage, we don't have power supply as I speak. So those are the 4 things ranging from environment, health, energy, and economy. Where does economic come in problem two? So next slide. Now, when I discovered this, there's abundance of energy coming from somewhere, and it's always there. But we don't have the chance due to clouding, which affected even the energy. Naturally, Earth is insulated from all these both direct and indirect solar supply, solar radiation. But due to constant or continuous degradation of ozone layer, we are left with this. It is discovered that up to the space of the last space of America is already just or such in the ozone layer, which is making the temperature increasing and at the same time increasing. Let's just say 1 million, which is 1 billion ton of carbon dioxide, is going to increasing as we are depositing 1 billion ton of carbon dioxide. We are going to be constantly increasing temperature on Earth, which is affecting polar regions, at the same time have debilitating effects on developing nations due to climate change, hurricanes, and let's just say floods and the like. Now, looking into the future, it is expected that we have alternative energy. We have alternative ways of cooling and heating. Another fact is this: heating and cooling alone is more than let's just say the energy consumption for heating and cooling alone. It's more than 40%, which is that for transportation, 30%, which is that for what we call another source of energy, maybe manufacturing and the like. So that brings about a solution concept, which is the SAS. What is SAS? SAS is solar absorption system. By virtue of that, how does it work? I explained the other time. It's azotic solar ice maker and contains component on this adaptive material. Same time we have condenser for the absorbate and the have that which is an evaporator. And lastly, when someone, the thing is this, it operates on 2 circles, 4 circles, but 2 circles are repeating, eating and cooling. During eating, the absorbate has already, during absorption, the absorbate has already absorbed into the absorbent. Then during absorption, the heat is going to be, let's just say, shining on the solar collector. So we are using solar collector to harvest the energy. So it's hitting on the absorbent, which is absorbent.
As a result of that, the methanol that previously absorbed into the material, like dissolve. After dissolving, goes through the condensation, with the condenser. So condenser is like heat exchanger. So the energy, the heat gained during absorption is ejected during condensation. Now the valve open so that the condensed methanol comes into the cooling chamber. So we have the two cooling chamber here. This one is the first cycle and this one is the next cycle. So from the cooling chamber, whatever we put there, either water, vaccine, fruit, whatever it is that we want to cool or that we want to condition, is going to the absorbent. This is going to take the energy and it's going to go through this reservoir. Next slide, please. Now this is the epsilon diagram. As I explained the other time, this is the eating part. This is where it is what we call dissolved. This is where it is cooked, and this is where it goes down with the absorption. So basically, what we are saying here is that the acidic heating happens from this place, from prayer. This prayer is likely, it's not just like it's a prayer of impacting prayer of methanol, which varies depending on the prayer within the system. Then after the eating is going to, the prayer is going to change, the prayer is going to increase as we are eating it, as we are eating the absorbent. Then it goes to the B. Upon B, you see that we have W2. That W2 is the amount of methanol that is dissolved after eating. Then it's going to maintain it at dissolvation rate of high temperature and period of condensation. So this is our condensation, this is our dissolvtion, so this is our absorption during cooling. And lastly, which is the what we call the absorption for the A to B. Next slide, please. Now, basically, so the four phenomena that we have there, solar radiation, which is common, mass and heat transfer calculation, which is number 2. So the first one is the net solar radiation, which is obtained from FAO 1998. What does it mean? It means the net amount of solar radiation that we can get from the sun. Now, it's dependent on albedo. What's the meaning of albedo? ALB. The ALB is talking about the reflection that we have and the amount of amount of energy, the incident energy, or let's just say solar irradiation that we have. Then another one is reflected radiation, is calculated from this expression. Then the solar radiation is dependent on two things. When angle of deflection, let's say deflection, so to say, at the same time, it's dependent also on latitude. Now, by latitude, I mean the angle based on a geographical, let's just say, map, the angle from North Pole to South Pole, that's our latitude. And from east to west, that's our longitude. So our declination is dependent on latitude and declination. So what's declination is the angle the Earth makes with the polarity of the sun. So now next slide please. Look. So now these are solar insolation. By insolation, I mean the amount of energy that comes to Earth, depending on temperature. Now, the higher the insolation, which you can see at 1 o'clock here, at the same time, you can see also at 4 o'clock here. So that means that's the peak that we have. So, and also the evaporator temperature and the ambient temperature are also projected based on the place temperature. So you see that our place temperature follows the same curve of our insolation, telling us that the moment we have highest insolation, we have highest what's it called, place temperature. Next slide, please. So this is now based on the numerical part. These are the component sizing of all the materials selected. Next slide, please. Next slide. Now this one is for collector collection, the solar collector calculation, and other calculation. Next slide. Now the material selected, the most let's just say effective based on current technology, the most effective material is HK3 and it is produced in China. It has the highest absorption capacity and quantity by 3.750. Just like this. Just like now. Now the based on the CLA and the mass of the ice produced. Now this is the based on the previous calculation. This is the maximum amount of what's it called solar production, the solar production rate. So we can see that it's around 55%. So we have 55 kilogram of ice being produced by our just like this. So this is the correction of performance if we are operating our emitter at this temperature, at ambient temperature, which is 45 degrees, depending on the location we are operating, just like this. So this is the ice maker, so to say, just like now. The competitive analysis is this. Now, in Nigeria, the emission factor for coal-based power plants, where we generate our electricity from, is 0.5 kilogram CO2 per kilowatt-hour, meaning that it produces 0.4 kilogram per every kilowatt-hour expended. Now, based on the fact that, based on the mass of what is produced in a day, let's just a week, so to say, for 1 ton of ice to be produced, we emit a particular amount of oxide, right? Then if that happens, the required refrigeration capacity, which is required, basically we have temperature at 7 degrees, then we are taking it to 0, we are maintaining it. So we have 2 energy to deal with, the sensible one and the related one. Now the capacity is 9.2 kilowatts to maintain that. Now I'm assuming let's just say the highest COP that we can have for people compression system, because fuel compression system, so to say, has very high COP, right? I don't bother considering the solar panels, what's it called? Solar panel, PVC powered refrigerator. Hello. Afis, oh, okay. Hello. You have really lectured us today. I think you will make a very good lecture. Only that you will not making eye contact. All right. Well done. I'm sure you've put in a lot of effort into this. My only comment is that when you're presenting, please don't ever stay in the line of the projector light. Except you have a pointer, you do not need to go and touch the screen. All right? Well done once again. Thank you so much. I should have said that. That's why I showed the what's called four punishment that big step for the apparent. Now basically it replaces both the pair, the absorbent pair now replaces compressor. That's what it does. It replaces compressor. Now instead of you connecting your compressor to electricity, no, don't do that again. Any of the working pair, like based on current knowledge, it's absorbent with like the activated charcoal ethanol that has highest activity. That's how it goes, Peter. Now it replaces, so to say, it replaces.
You know, we have the compressor now, we have the condenser, we have the adiabatic expansion valve, then we have the evaporator. That's just the basic principle of the reaction. So where is your aluminium coming in?
That's exactly.
That's what you are not going to market it to.
Exactly. Now,
All right,
so activated carbon, that I'm saying the work it did is not just activated carbon alone, or activated carbon with methanol. Methanol that is evaporating into absorbing into adsorbent. Now, which by virtue of latent vaporization of methanol effectively. Each exchanging medium are two, evaporator and condenser. Now the fluid that goes around, the one that's what they call isotope of exhausted. The isotope of just saying amount of ethanol that absorb into the adsorbent.
Yeah, I think I'll focus more on, I think, your presentation style. In the first instance, you are not engaging the audience, but most of the time you are looking at, you don't know what to do. You are not engaging the audience. And I think your slides are too wordy. Whatever you have on the slide, you can read. So you don't really, in the beginning, yeah, you are not reading what's on the slide, but you are sort of like going too far away from the subject of the presentation. So I want of the subsequent presentation, you need to, you probably want to put less wording on your slide and talk more about what you want to present. When you're talking about what you want to present, also manage how you attend between what you call literature review and the substance of your presentation. That's one. Two, your cost benefit analysis is not clear to me again. The impression you're giving here is that I can have a complete fridge for 350,000 that doesn't require electricity. If I just look at it on face value, maybe you can explain that better. I think that's two.
Now, the reason why it's this expensive, let's start with because it is quantity based. By quantity based, the more you buy, the less it becomes. So by virtue of this, now by virtue of the operating cost, by like amount of money you need to keep operating the operation revenue system, keep operation revenue system. The energy you are going to require to do that is 13,490 kilowatt hour for 1 ton of ice that you are producing. Right now, if that happens, by virtue of the fact that the cost of 1 kilowatt hour in Nigeria is 0.024, right? Then when you multiply that, you get $354 US dollar, right? Now the payback time just operating it alone is 11 months. Just operation, not the first cost of the labor compression is not put in place now. So when you factor in the cost of the refrigerator or air conditioning unit with the cost that you are going to use to operate it, maintenance is not even there. Maintenance is not even there. So Yes, but the condition is it has to be the graphic period has to be. That's just the technique. Exactly, exactly. That's why I did it for a period of a year, so to say, operation. Yes. But not you are spending money on my solution. Rather, you are spending money on people compression system. Exactly. Yes, exactly. That is $300. Why we are saying this is that it's actually a simple payback period that was used. Now, how much if you start, let's say you buy now, this is my product you are buying now, and you are buying this also. Apart from the first one, my own first cost is $300, right? The operating cost in a year, which like is 11 months, like in 11 months time, and what you're going to use to maintain this, just to maintain it alone, you buy the product.
Hold on. I have just a few comments. First, I believe all of you are here. Get feedback on what you do. There's one presentation, there's a learning part of it. There's something you need to learn, and that is listening to understand and not just listening to respond. You may have a very good solution, and you have a lot of passion. Passion is helping you improve what you are. So, more very important than what you invest in, not responding to what you are saying. That is why personal feedback. I think the other way when you dose your presentation with comments, it distracts you. That's one. Two, when this one is feedback by the first person, the presentation was in fine print, I mean small print. I can't read small print. And squint into this small print. Now, it is also the same thing as you having too many things. Like the lecturer that was here many years ago, I don't know if you remember, Dr. DJ. Dr. DJ taught us something. He said, cover less and cover more. And there's still to that. What you try to do is do lots of the lot of the material and you lost of you again you know that you are working in a very technical area. Your skill should be let me not talk too technical, but I understand technical. So if somebody wants to get technical, that's actually you start bringing it up. But what you've done is like you know about everything about absorption respiration and deal with but your case is better than the first person. The first person did everything about I personally was excited about you hearing about the first person. But he did everything to say, oh, there's a magic I have to show you people. It's coming up. They people in on you. They did their best to say what they wanted. So you haven't done I'm giving you feedback. You have to take it. You haven't done justice. And you took but I'm more delighted with other people who have done it. Cover less, cover more. And since this thing is very technical,
tell us benefits, tell us how you get it, just stay in that. I need somebody who wants to. When you learn your analyst, you don't get it. So before we move on to the next thing, yes, one of us here like a color. Like a color. Like a color. Thank you very much. All right, so I'll move there. I should ask me to do it, but I tasted this beauty. Tasted this beautiful thing. I know I'm spending my allowance on this. So she contributes this. I got it. It's very sweet. I like to drink it, but people have money. If you spend on your sport money, then candy as well. I know somebody that will purchase this and jam as well. So if you are interested, see me, I'm a distributor. Don't see her directly for the price. See me directly. I will tell you the price. Don't see her directly. I'm a distributor. Also, supply chain. So moving right. So now back to our panelists. So from our panelists, if you have anything really good things to bring to the presentation, and you want the audience or the panelists themselves to learn from any general comments.
Okay, thank you very much. I will sincerely like to commend all the presenters. I am very much impressed with the level of the ingenuity and the depth you went, knowing that this is just a BSc final year project. I think you have done very well for yourselves, and you should be proud of yourselves. I'm particularly impressed because I was discussing with Dr. Adebayo here that my project students in the Department of Food Technology, they know that you will not do any project with me that is not market driven, does not have a demand in the market. It is something that somebody will need. So you must first go and do like the market validation to come and tell us how many people need this. And I think what you have presented is very innovative. In case you do not win, okay, and for those of you that have dropped along the way, don't see what you have done as not good enough. Give it more. The feedbacks you have gotten and that you will still get from your supervisors, give it more, go further, and you will see that you can actually make wealth, create wealth from what you do by yourselves. All right. For the presentations, I would particularly want to commend the guy that brought his own that we can actually see. Okay, it makes it more relatable. It makes somebody wants to say, okay, I actually very much understand what you're presenting. So I think it is very good that you showed us and you told us the problems you have encountered. Somebody would say that output you got, you said 55% was low, but then you told us the challenges you had and what you are going to do to correct it. I think that is very good. Once again, I commend all of you. The first guy, you are a very good presenter. Even when you had challenges with the microphone, you made it flow very well. You can explore public speaking. a very good presenter. And the lady as well, I'm very proud of you. You are not intimidated, and you have been able to hold your ground. Well done.
Okay, thank you very much, everyone. I think it was very showed that you guys have put a lot of hard work, to your presentation. And like she mentioned, while I just don't want to pick out one particular person, when you have an opportunity to pitch, right? So you assume this is not a it's not a technical presentation, it's more commercial. Right? So you have to show the commercial side of things. You have to show the naira cover, right? Show that there's a market, right? Show that your solution is solving a problem, right? Show that people will be happy to pay, and they will be happy to pay X amount for this product as against Y that they are currently paying for, right? In every pitch, it's a sales pitch at the end of the day, right? You've done the technical bit in putting all the stuff together. What you are coming here to say to us is, look, this product is good, it's going to solve a problem, right? And you should buy this instead of buying that, right? And I think, yeah, yeah, right. I think you did that very well. So well done to everyone. But I have to single him out to say he did a really good job. But I enjoyed the presentation.
All right, thank you very much to panelists and panel. So we'll take a short break. Let's network and we'll give time to our panelists to begin their scores. So I think there's a room there. If it's not too much space, what to discuss.